Okay, as far as wireless security is concerned, or the security in VLANs are concerned, we have some extra stuff. That's called Wireless Application Protocol, okay, WAP. WAP. And this is generally designed for a universal open standard to provide mobile wireless users access to telephony and information services. So if you are using your phone to access your bank account, okay, in this wireless environment, you're going to use WAP. Okay, so that is the idea about WAP, wireless application. Have a significant limitations of the devices, networks, displays with wide variations. So in other words, when you get the website of Bank of America by using your cell phone, the website that you are getting might be or could be different than the actual website, because they are gonna rearrange that website. They are gonna make that website suitable for your phone to present basically. And you are running limited browsers, so on and so forth. Although the phones are getting quite powerful right now, but generally that is the case. So WAP specification includes programming model, markup languages, small browsers, lightweight communication protocol stack, and application framework. So what I'm saying is this. There will be a WAP gateway, okay, and there's a client, and this is WAE client agent, I should say. And this user agent will request something for this from this original server, and the gateway is going to send that request. And there will be a CGI scripts, and there is the content. This content is going to be rearranged, okay, depending on your abilities over here, and it's going to be sent back to you, okay, so that you can see, you can access that content by using your limited power device, mobile device that is, okay. And this is the infrastructure. Let's say that this is the mobile terminal over here and wireless palm top. And if that is the case, for example, there's ordinary web server and there's VML capable web server. VML is the wireless markup language that is used for this environments, okay. So if it is ordinary web server, you're going to get the original data, but that's going to be VML over HTTP, okay. And then there will be a WAP proxy, and that proxy is going to send these things based on the devices that you are using. So there is a change over here on the VML, okay. Content is going to be modified. Okay. What do you call those technologies when you remove something from the website and make it available for your cell phone? That's called clipping, right? Am I right? So check that out anyway. And as far as I know, it's called clipping. And in clipping, what we are doing is we are actually modifying the original website, okay, and we are making the original website suitable for the devices that we are using, which they don't have display capabilities like your computer, okay, and which they don't have enough computation power to compute all these animations and so on and so forth on the original website. Okay? You are not going to see those animations anyway when you access it with your phone. Okay? They are going to remove all those things. Okay? So let's have a look at this VML. What is that VML? Wireless Markup Language. Describes content and format for data display on devices with limited bandwidth, screen size, and user input capability. Okay? Features include text image formatting, deck card organization. So they have deck cards actually like file folders. Okay? So you're going to go and get the stuff from those deck cards. Okay? And support for navigation among cards and decks, basically. Okay? A card is one or more units of interaction. A deck is similar to a HTML page. They have that kind of structure. So this is the architecture of WAP. You see there is a service discoveries over here, provisioning, navigation discovery, service lookups. So when you go somewhere, you are looking for ATM device, for example, okay? Your phone is going to find it. It's a discovery, a directory discovery service, for example, okay? And security, crypto libraries, they have a lot of crypto. Authentication is required. The identity, there are a bunch of mechanisms that they have for identity. PKI, public key infrastructure, so they can use the standard certificates for security. Secure transport, well, that's very good. This secure transport is actually, guess what? TLS, transport layer security, or SSL protocol that we are using in wired environments. So we're going to call that WTLS, and I'm going to show how that WTLS is working actually. And secure barrier, so those guys may have actual security carriers, so that maybe they can have some IPsec lines or something like that, but they may have a special secure barriers to carry the messages. Okay? And if you look at the application framework, any multimedia messaging is going to be supported. Okay? Content formats is going to change based on WML. Okay? And you may have push mechanism, and there are the user agents. For the session services, there will be cookies, push OTAs, and synchronizations. For the transfer services, hypertransfer, streaming, message transfer. For transport, that is datagram and connections, connection-oriented, connectionless kind of stuff. And the carrier networks could be IP version 4, IP version 6. Actually, the secure barrier comes from the IP version 6 anyway. It is part of IP version 6. And also all those things that you know can be used as a barrier networks. Ghost, GOTS, Flex, SOS. Okay, these are all available over here. What is important for us in this architecture is this security part. Okay, this security part. So how are we gonna provide the security? Okay, this is the actual way that these guys are working. There will be WAE. This is the agent. That is you, your device. Okay. So when you create something, it's going to go to WSP, WTP, WTLS, and WDP. And it's going to go to the gateway, and gateway, let's say that this is the original web server on your network site. Okay? In network site, that is HTTP, TLS, TCP, IP, but corresponding wireless site is going to be WSP, Wireless Session Protocol. Okay? WTP, Wireless Transport Protocol. WTLS, Wireless Transport Layer Security, in other words, wireless SSL, okay? And the WDP, Wireless Datagram Protocol, okay? Datagram Protocol. You see, they have this structure. So this structure is going to be converted to this structure, or vice versa, in the gateway, so that the WAP device can communicate with the actual web server. Okay? Are we clear with this? As you see, we need a WAP gateway. Without that WAP gateway, there is no way that you can communicate with the actual web server. Right? Okay, so let's have a look. Wireless Session Protocol, WSP, provides applications to sessions in services. Okay? Connection-oriented and connectionless, and based on HTTP with optimization. So it is using HTTP, basically, but with optimization. So in other words, you are not going to have all the HTTP details. Okay, it's going to be limited HTTP. In other words, Wireless Transaction Protocol manages the transactions of requests, responses between a user agent and application server. And then in the previous slide, I said Wireless Transport Protocol, but this is actually Transaction Protocol. Okay, provides an efficient, reliable transport service. So it is Wireless Transport Protocol, in other words. It's replacing the TCP a little bit, okay? Because if you remember, TCP is going to be reliable communication protocol. Wireless Datagram adapts the higher layer WAP protocols to communicate. Provides security services. This datagram protocol is going to replace a little bit the IP protocols, basically. And this is important for us, WTLS. That's the security part of it, okay? Provides security services between mobile device and, this is important, and WAP gateway. Provides security between client and WAP gateway. That means it does not provide security between source and destination. So there is no end-to-end security, in other words. But there is a security between agent and gateway, and most probably gateway and server, destination server. But it does not provide end-to-end security. Don't forget that one. Okay? And it is based on TLS, but more efficient with fewer message exchanges, so it is limited version of SSL. Okay? Use WTLS between client and gateway. You see, that's not client and server. So it does not provide security between client and server. It does provide security between client and gateway. Okay, so that's important. Use TLS between gateway and target server. So in the wired site, you can go and use actual TLS. So what I'm saying is this. Agent and the gateway, okay, in other words, client, WAP client and the WAP gateway, you have WTLS. Gateway and the destination server, you have actual TLS. Okay, you have actual TLS. So that is the idea. This gateway is going to convert WTLS information to TLS information, basically. Okay? So what is this WTLS? We're going to have a connection session, secure connection and secure session. In secure connection, we're gonna have some associations. So in this connection, we're going to define what type of stuff we're going to use, and each connection is going to have one related session. Okay, one related session. And when we come to the secure session, an association, this is an association between a client and server, okay, created by another protocol. It's called Handshake Protocol. Handshake Protocol. So this is part of TLS. TLS is not one single protocol, guys. Okay? TLS has record protocol, which encrypts the data. TLS has Handshake Protocol, which is a major part of the protocol. And the other one is Cipher Spec Protocol, Cipher Spec Change Protocol. We change the cipher spec. And the fourth one is giving the warnings and errors, those kind of things, basically. 4 different protocols made up whole TLS protocol. Okay? But as I said, Handshake is the major one. Because in Handshake Protocol, what we are doing is we do define set of cryptographic security parameters. In other words, we do define which algorithm I am going to use. What is the key size? Which keys is I'm going to use? Which IV I'm going to use? Which MAC I am going to use? Or which hash I am going to use? These are going to be the keys for those hashes, for those MACs. And when we define those things, this is not just one key is going to be used between client and server. Directions are going to be important for us as well. If you are transmitting something from client to server, you will have some key set for encryption for MAC. Okay? And if you are transmitting a message from server to client, you're going to have another keys, encryption and integrity keys. And also you will decide which key distribution technology you're going to use. Okay? Or everything is going to be decided over here. Okay? And with some random numbers as well. Because we're going to use those random numbers to create the keys. And this is shared among multiple connections, by the way. So what I'm saying is this. Handshake Protocol is 1. Change Cipher Spec Protocol is 2. Alert Protocol is warnings and everything is 3. And Record Protocol is 4. These 4 protocols made the TLS. Okay. In actual networks, TCP is going to carry that information. Okay. But over here, VDP is going to carry that information. Okay. VDP is going to, or UDP over IP is going to carry that information. What is this change cipher spec protocol? An idea? What we are doing in SSL, in actual SSL is this. Every computer or every client has some capabilities. For example, I can have the Diffie-Hellman key distribution algorithm and RSA algorithm for key distribution. I can support this too. And for encryption, let's say that I have AES on my computer. Okay? And for Mac, I have SHA-1 based HMAC. Okay? This is one combination for me. Okay? Key distribution, encryption, and Mac algorithm. I'm going to have a list of this based on different algorithms. For example, I will say, hey, for encryption, I have RC4. For Mac calculation, I have CBC Mac, AES based. And for key distribution, I have RSA. 2 options. I don't know what you have. So I'm going to send my options to you. This is called Cipher Suite. In Cipher Suite, I'm going to have list of all the algorithms that I do support. Okay, key distribution, encryption, and MAC algorithms. And I'm going to send my list to you. Okay, and you're going to check my list, and then you're going to send your list to me as well. Okay, then we're going to find one combination for key distribution and for encryption and for integrity, for MAC calculation. One combination which is the most secure, most strong as far as security is concerned, and which is supported both of us. And we will decide about that one. That's called change cipher spec protocol. So that we're going to change the cipher spec. We're going to say that I'm going to use RSA for key distribution, I'm going to use AES in CBC mode for encryption, and I'm going to use HMAC SHA-1 based. That's it. We agreed on that one. Okay, if you agree on that one, if you make that one your current spec protocol, okay, then what are the parameters? For example, RSA, what are the keys that you're going to use? Okay, and then RSA is going to distribute AES keys, okay, and you are using SHA-1 HMAC. What is the key that is required for that one? And what is the IVs that is required that one? All of those things are going to be decided over here. Okay? All the needed information, security-related information, will be calculated right here. So we calculate the keys. Keys are ready. We decide about the algorithms that we are using. What I'm going to do is I'm going to call this protocol. This protocol is going to use those parameters to encrypt the data, to calculate the MAC and everything. They're also using compression techniques over here. They're compressing the data, then they are encrypting it to make it faster. Then it's going to be sent to WDP. Okay, that's the whole idea. So let's have a look. How are we going to do all those things? User data, compress it, calculate the MAC, append the MAC to the data, encrypt the data with whatever the algorithm that you decided. Okay, append WTLS record header over here. This is the record protocol. Okay, it is encrypting the data based on the parameters, based on the algorithms that you decided in Handshake Protocol. By the way, these are user transparent. You are not going to sit down there and you're going to say, oh, okay, I want AES or I want... No. System will handle it. When you have HTTPS connection on your web browser, okay, do you say anything about which algorithms you're going to use, which keys you're going to use? No. System is handling it between client and server. When they decide about all those parameters and everything, then HTTP becomes HTTPS. Okay? And then record protocol is going to encrypt everything. Change cipher spec simplest to make pending state current. That means whatever the combination you selected is going to be your current state. Okay? Alert protocol is going to use warning messages, blah, blah, all those kind of things. For example, it will say that the certificate is not available or certificate is not belong to this guy, or those kind of things. What is important for us is this one, Handshake Protocol. Okay? So let's have a look, negotiate encryption, MAC, keys, everything is going to be right here. Okay? Because if that doesn't work properly, we're going to be in trouble. So that is the summary of that one. They are going to send hello messages, client and server. This hello messages is going to establish capabilities including protocol version, which protocol version you are using for TLS. Okay. Session ID, they are going to have an ID for the session. Cipher suite, list of the algorithms that they do support. Compression method, which compression method they are going to use in the record protocol. And initial random numbers. They are going to exchange some random numbers. We're going to use those random numbers. I'm not going to go into the details, but we are going to use those random numbers to create those keys and all those cryptographic things, basically. Okay, so we exchanged all this information. If I have a certificate, that's called X509 certificate, that's standard, okay? I'm going to have these certificate exchange messages, okay? If I don't have a certificate, I'm not going to have these three messages. I'm just going to have server hello done message, okay? In server hello done, server may send certificate key exchange and request certificate or server signals end of hello message phase. Okay, I don't have certificate. I'm done. Okay, let's go. with our lives, in other words. And client, if the server requests certificate from client, if the client has certificates, client is going to send the certificates. Certificate means they are exchanging their public key information. RSA public key informations. Okay? They are exchanging their RSA public key informations. If they don't have it, they're going to skip these parts. Then this guy is going to say, I selected this cipher suite, and it's going to send finish message. And this guy is going to say, okay, we selected this. Generally, when the server selects something, it's going to be accepted. These finish messages are quite interesting. Actually, we have those kinds of stuff over here too, but if you don't have certificate, we're going to skip that part. These finish messages, what they are doing is they are actually calculating the hash of all the messages that is exchanged up to this point. And this guy is also calculating all the messages exchanged up to this point for both sides. And if the hash calculation, that generally they are using hash calculations for that one, if those hashes are the same, they will say that, hey, okay, we exchanged the parameters correctly. Okay, so they are verifying that they actually exchanged the parameters correctly. Okay? That's very nice control mechanism, by the way. Hey guys, you guys are using this every day. Every day. This is the protocol that you are using. As I said, when HTTP becomes HTTPS. Okay? That is happening over there. And most of the time, you are not using this certificate stuff. Okay? Yes? It is optional. Certificate usage is optional in SSL. If you don't have it, you don't use it. If you have it, you may use it. That is for the exchange of the public keys. Okay, let's put it this way. What is the question is, what is the usage of certificates? In other words, what is the certificate? I said that the original name for certificate is X509. X509. There are companies like VeriSign. Okay, their main job is to create these certificates. This certificate is created to solve one of the important problems in public key cryptography. That is the key distribution of public keys of the people. In public key cryptography, we have two keys, guys. One is public key, known by everybody. The other one is private key. You're going to keep it secret. Fine. The other one is public. Everyone has to know it. And if I want to send you an encrypted message, I have to use your public key. And you're going to decrypt it by using your private key. That is the way that we are using the public key cryptography. Okay. And you are telling me that this is your public key. How do I know that that public key actually is your public key? Someone maybe is posting that information saying that this is her public key. Okay. And certificate is a way to bind you to your public key so that without any argument, I can accept the certificate and the key in that certificate as your certificate. Okay, that is the idea of certificate. Why they are using it over here? Because they have to know their public key information so that they can generate or they can use key distribution. If they are using RSA key distribution, for example, they have to know each other's public key information. Yeah, go ahead.
Why is it optional? If they need the certificate and if it is not there, then what do they do? If they don't have their private and what is here, if they're willing to share their private.
Okay. As I said, for the key exchange, you have different techniques. Okay. One is RSA. The other one is Diffie-Hellman. For example, if they support Diffie-Hellman, here we go. You don't need those things. They can exchange those information. Or the other thing is that maybe in some specific applications, those public keys already known by parties. Okay, so that you don't need those certificates. Generally, we don't use, as I said, those certificates, and we do generate those keys with Diffie-Hellman, okay, and or pre-installed RSA keys. Your operating system crypto engines can generate those keys anyway, okay, and then they can exchange that information. Okay, are we clear? All right. So let's have a look. For authentication, WTLS uses certificates, as I said, X509. This is version 3 certificates, or X968, or WTLS optimized for, this X968 is for WTLS optimized version. And it can occur between client and server, or client may only authenticate server, depending on the conditions. Okay? And for key exchange, you see, Diffie-Hellman Anonymous, EC Diffie-Hellman Anonymous, RSA Anonymous. What is the meaning of these guys? Diffie-Hellman Anonymous, you have Diffie-Hellman with the problem of man-in-the-middle attack. Okay? With the problem of man-in-the-middle attack. So that is called Diffie-Hellman Anonymous. EC Diffie-Hellman, elliptic curve-based Diffie-Hellman. Okay? RSA, it's actual RSA. Right? And we don't need any ECDH, ECDSA, or RSA. Okay? Because these things are huge. They require a huge computation. Okay? Huge computation. So that you may not use those things for the key exchange services. Okay? And well, how we are generating those keys? We have a pseudo-random function called PRF. Okay? It is HMAC-based, uses for number of purposes. And it is only one hash algorithm agreed during the handshake. Okay? So they are using only one hash algorithm in HMAC that is going to be agreed in the handshake protocol. Okay? First of all, there will be a master key. Okay? And this master key is going to be generated from a pre-master secret, or pre-master key. Okay. Master secret, as you see, is going to be generated by using this HMAC, by using this pre-master secret, okay, and the name of the pre-master, or pre-master secret, and the random numbers that we exchange in the hello messages. Okay? So I'm going to do the macking of that one. I will get the master secret. This pre-master secret is going to be distributed by using either RSA or Diffie-Hellman. Either RSA or Diffie-Hellman. That we decided about the key distribution algorithm in Handshake Protocol. Okay? So we created this master secret. By the way, this PRF function is quite complex. It's not just one HMAC. It's a block of HMACs is repeatedly used. Okay, repeatedly used. And then we're going to derive MAC and encryption key based on the master secrets. It's going to be another PRF function. I mean, it's going to be the same PRF function, but this time input is going to be the master secret instead of pre-master secret. And there is a little bit change over here, and then output of that one is going to be the keys that we're going to use. Okay, we're going to use. And encryption is going to be RC5 based, or DES based, or triple DES based, or IDEA based. IDEA is another encryption algorithm. RC5 is also another encryption algorithm. Okay? I'm not going into details of these things. I'm assuming that you know already these things, okay, a little bit. I'm just giving or repeating the stuff that you may remember. Okay? We don't need those details anyway in this course. Okay? In this course. Just know that the keys are going to be generated from a master secret. A master secret is generated from a pre-master secret. Pre-master secret is distributed, okay, with the algorithm that is decided in the handshake protocol. That is the whole idea of this WTLS handshake protocol. Alrighty. Okay. So we don't have end-to-end security. Security in WAP is going to be something like this. WAP device. Between WAP device and WAP gateway, we're going to have WTLS. But between gateway and the server, we're going to have actual TLS. Okay, actual TLS. So the data right here is going to be in what? You guys tell me. What is the problem with this one? Yes, data is going to be over here in clear form. Because to convert this TLS to this TLS, you have to decipher the data, because the protection is only between on this channel. When the data comes to the gateway, it's going to be in clear form. Any security compromise over here, you are in trouble. Everything is going to be clear. Okay? So everything is secure in the channel, in the wireless channel. But data is not secure in the WAP gateway. So they are trying to solve this problem. Okay, they are trying to solve this problem. One is this, TLS-based security, and the other one is IPsec-based security. In TLS security, what they are doing is they are actually using the actual TLS on the devices, because right now the devices are becoming quite powerful. Okay, so that there is no conversion. Am I right? So let me put it this way. They are using TLS. TLS information is carried by TCP. But if you have a router which works on TCP, it does not care about the encrypted data, because TCP payload is going to be in encrypted form. Right? Your record data comes from TLS. It becomes TCP payload, right? That's going to be in encrypted form right here. Okay. So over here in the gateway, this is TCP gateway. When we come to TCP, TCP header is in clear form. All I need is a TCP header and IP header anyway. I don't care about the payload. Payload is encrypted. I'm just translating this to this one in form of headers. Nothing else. I'm not touching the data. And data is in encrypted form over here. It's not in clear form. Right? So I can have this solution. Or the other thing is the IPsec. My router works on the IP level. Okay? If that is the case, I can have the security at the IP level. Okay? HTTP, TCP, and I'm going to have IPsec over here. That's going to provide the security at the IP level. Okay? At the IP level. Again, data on the gateway is not going to be in clear form. Okay? It's not going to be in clear form. That's called WAP2. Okay? WAP2. Previous slide was WAP, and this one is WAP2. And in WAP2, we have this kind of two scenarios, either TLS-based or IP-based, IPsec-based solutions for the end-to-end security. And this is a little bit more complicated. Another scenario, what they are doing over here is that, let's say that this domain, enterprise domain, is a secure domain, okay? And then this guy wants to access to the application server or the web server over here, okay? And it goes its local WAP gateway, and WAP gateway comes over here and sees the web server, but web server says that, hey man, I have to have a secure connection with this guy. It sends a message and it gives this actual gateway which is secure, okay, for the enterprise, and then this guy accepts or rejects that offer, okay, and sends it to the terminal, and the terminal gets connected directly to this guy until they are done, okay, until they are done. So this way, they are going to provide the security already right here in the second connection, because the actual data exchange is going to be in the second connection, and it is under the control of the enterprise anyway. Okay, under the control of the enterprise. Imagine that you are accessing your bank account on the web by using your phone. Okay? Well, most probably this is going to be the case. Most probably. Well, maybe some banks are not using this one, but as I said, most probably this is going to be the case. They are not going to allow anybody to gain access to their web servers or the application servers by using some default gateway that they don't control. They are going to tell you that, hey, go and access to gateway, because that gateway is under my control. I can control everything over there. So that is the other mechanism, okay, other mechanism to provide end-to-end security in WAP. Okay, so this is also called WAP2. Okay, WAP2. Alrighty. Okay, conclusion, finally. So we are done with this chapter. What is our conclusion for this chapter? Security is too complex and messy. Okay, it is not easy. Well, it is not easy. Believe me. Okay, it is definitely not easy. That's why it is becoming more important these days, because things are getting more complex. Not just security, systems are becoming more complex, and providing security is going to be even more difficult. Okay, even more difficult. So security is not an ant, as you see, but a means not a product, but a process. So you don't have 100% secure product, in other words. What you have is always improving and doing something to provide security. That's why it is a process. Okay, you are not going to get something as a product at the end. When you think that you get something, you will be wrong, because something will happen. You will understand that there's not enough security over there, and you're going to provide that security, or you're going to fix that part for the security. That's why right now in today's world, as far as security is concerned, things are moving to management side, managing the security, finding the vulnerabilities, finding the risks, analyzing those vulnerabilities, analyzing or managing those risks are becoming a little bit more important. People are not sitting anymore to break a system, sitting somewhere and trying to break the RSA keys or trying to break the AES key. And we said that AES key is 128-bit, right? So to break that key, they have to search to the power 128-bit key size, huge number. Okay? They're not going to spend time. But instead, if they know some vulnerability, some weak point in Adobe Acrobat Reader, they are going to exploit that one to gain access or to do something on your computer. If you are not aware of that vulnerability, okay, you may be in trouble even though you are using 128-bit AES algorithm. Okay? So that's why right now, as I said, risk management, vulnerability analysis, okay, all those kinds of management things, enterprise security planning, becoming really important.